Good evening, students. Welcome back to chemistry class. Today, let us continue the lesson carbon and its compounds. In the previous classes, we have learned the bonding in carbon, the covalent bond, and allotropes of carbon, diamond, graphite, and fullerene. Then the versatile nature of carbon. That means why carbon is forming such large number of compounds. The reason is one is catenation, other one is tetravalency. Then we learn what are saturated and unsaturated carbon compounds. We learned isomerism and its examples. Then we learn functional groups. In that, 5 classes of organic compounds we learn. That is chloro or bromoalkanes, alcohols, aldehydes, carboxylic acid, and ketones. Next we learn homologous series. Then how to name the carbon compounds, that is nomenclature of carbon compounds. Today we are going to learn the chemical properties of carbon compounds. Among the chemical properties in this lesson we are going to learn 4 chemical properties. One is combustion, oxidation, addition reactions and substitution reaction. Let us see the first one, combustion. What is meant by combustion? Burning. Burning in oxygen. You know oxygen is required for burning. So you have learnt already that when carbon burns in oxygen, what is the product formed? Carbon dioxide. So like this, all the allotropes of carbon when burned in oxygen, carbon dioxide is formed. So carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with the release of heat and light. So a lot of heat and light also produced when carbon burns. The same way, most of the carbon compounds also releases a large amount of heat and light on burning. So carbon compounds when they are burned, the products formed are carbon dioxide and water along with the heat and light. Let us see the examples. C plus O2 gives CO2 when carbon in all its allotropic form burns to form carbon dioxide and heat and light. Next one, carbon compound CH4. Which is CH4? Methane. Methane when burnt in oxygen, when it undergo combustion. What are the products formed? Carbon dioxide and water along with the heat and light. Let us see another example. CH3, CH2OH. Which is this compound? Alcohol having 2 carbon atom, that is ethanol. When ethanol undergo combustion, what are the products formed when it is burned? Carbon dioxide, water and heat and light. Now let us see one activity. Take some carbon compounds. We have taken 3 carbon compounds, naphthalene, camphor and alcohol. One by one on a spatula and burn them. Now what we have to do? We have to observe the nature of the flame and note whether smoke is produced. So when each one of this is burnt, what is the nature of the flame? Whether we are getting a clean blue flame or we are getting a sooty flame. Sooty flame means a flame which forms the soot. That means smoky flame. Then place a metal plate above the flame. Why we are placing the metal plate? To note down whether it is non-sooty flame or sooty flame. If it is non-sooty flame, no accumulation of carbon will be there on the bottom of the plate. If it is a sooty flame, we can see carbon particles are accumulated at the bottom of the vessel. Here carbon particles are accumulated, we can see. So is there deposition on the plate in case of any of this compound? So let us see the result. So which are the compounds we have taken? Naphthalene, camphor and alcohol. You can see here when naphthalene and camphor are burnt, you can see a yellow smoky flame, sooty flame is produced. When alcohol is burned, you can see a blue flame, a clean flame. Now let us see what is the reason for this difference. Camphor and naphthalene will burn with yellow sooty flame because they are unsaturated. Why it is called a sooty flame? Because the carbon accumulation of carbon on the metal plate we can see when these are burned. If we are showing the metal plate above this flame. The soot is one of the allotrope of carbon. Soot, or it is also called lamp black. The carbon which is accumulated on the bottom of the vessel, that is nothing but the allotrope of carbon, soot. That's the reason it is called a sooty flame. Now, why this camphor and naphthalene form a yellow sooty flame? Because these compounds are unsaturated. What are unsaturated and saturated carbon compounds? You have learnt already. Unsaturated carbon compound means there should be double or triple bond between the carbon atoms. What are saturated ones? Saturated carbon compounds. All the carbon-carbon bonds are single bonds. Now, alcohol will burn with blue non-sooty flame because it is saturated. So, we have seen now saturated compound undergo combustion. It will burn with a non-sooty flame, that blue flame. And unsaturated carbon compounds undergo combustion. It will burn with a yellow sooty flame. Can you say what is it? Why this difference occurs? For example, we'll take three examples: ethane, ethene, and ethyne. You know the molecular formula of ethane is C2H6, ethene is C2H4, ethyne is C2H2. In C2H6, the carbon content is less. There are more hydrogen atoms. So, percentage of carbon is less. So, it undergo complete combustion here. In ethene and ethyne, carbon percentage of carbon is more. Ethene is C2H4, ethyne is C2H2. The percentage of carbon is more. So when it undergo combustion, incomplete combustion takes place and a few carbon particles will be left over there. This is appearing as the soot. So in camphor and naphthalene, there would be residue. Residue means the leftover solid substance because they are unsaturated hydrocarbons. So we can see here saturated hydrocarbons, the carbon content is less. Due to that, it undergo complete combustion. So it burns with a non-sooty blue flame, clean flame. And if unsaturated carbon compounds undergo combustion, a carbon residue will be left over there, that is appearing as soot. So it burns with a yellow sooty flame because the carbon content is more in the case of unsaturated carbon compounds. Next, let us perform another activity. Light a Bunsen burner and adjust the air hole at the base to get different types of flames or presence of smoke. That means what type of smoke we are getting. We are getting a clean flame or sooty flame. When do we get a yellow sooty flame? When do we get a clean blue flame? So this is a Bunsen burner. We are using the laboratories and all heating something. We are using the Bunsen burner. So here there will be air holes. The air holes will adjust in such a way that then we have to see when we will get a sooty flame and when we will get a blue flame. So we can see that when air holes are blocked, we will get a yellow sooty flame. When there is sufficient supply of oxygen, that means availability of oxygen is enough, sufficient, we will get a clean blue flame. What does it indicate? There is sufficient amount of oxygen, complete combustion takes place and we will get a clean flame. If air holes are blocked, we are not getting, the substance is not getting to burn the sufficient amount of oxygen. So, a sooty flame, incomplete So due to this incomplete combustion, yellow sooty flame is formed. So we have seen now, in short we can say, when the carbon compounds is saturated one, it undergo complete combustion and will get a blue flame, non-sooty flame. When the carbon compound is an unsaturated one, it undergo incomplete combustion and will get a yellow sooty flame. Then one more point, even though the carbon compound is a saturated one, if sufficient amount of oxygen is not available, it undergo incomplete combustion and will get a yellow sooty flame. So in short we can say saturated hydrocarbons will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame with lots of black smoke. And one more point, however, limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. Now one more example we'll take. Everybody's house there is LPG gas and we are using the gas stoves. So when the gas or kerosene stoves what we are using, it has inlets for air so that a sufficiently oxygen rich mixture is burned to give a clean blue flame. So you might have observed in your house, if the burner is very clean, air holes are not blocked, sufficient amount of oxygen is available and it burns with a blue flame, you can see. And sometimes we can see if you are cooking something, anything is spilt over there, these air holes are blocked or any dust particles are there in the burner. The air holes are blocked and will get a yellow sooty flame. So the bottom of the cooking vessels getting blackened, it means that the air holes are blocked and fuel is getting wasted. So when the air holes are not blocked, sufficient amount of oxygen is there, we will get a blue flame. If air holes are blocked due to the dust particles, we'll sometimes will get a yellow flame. So one more thing we can observe that if it is a blue flame, bottom of the vessel will not be blackened. There is no deposition of soot. If it is a yellow flame, we can see accumulation of black things get deposited on the at the bottom of the vessels. Next, the fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. Their combustion results in the formation of oxides of sulfur and nitrogen, which are major pollutants in the environment. So we know already coal and petroleum are they causes the pollution. What is the reason for this? In coal and petroleum, there are some amount of the elements like sulfur and nitrogen. So you know when sulfur is burned, sulfur trioxide, all these gases are formed. And the nitrogen is burned, oxide of nitrogen is formed when nitrogen is burned. So the sulfur, oxides of the sulfur and nitrogen are pollutants. They causes the pollution. That's the reason the petroleum and coal will cause lot of pollution, air pollution. Next, let us see one point. Why do substances burn without flame? You can see some substances burn with flame. For example, a candle or LPG in the gas stove burns with a flame. And sometimes you can see coal or charcoal just glows red and gives out heat without a flame. You might have observed this. There will not be flame, they will just glow. Can you say what is the reason? The reason is that only the gaseous substance undergo burning. They produce the flame. So this is because flame is only produced when gaseous substances burn. So in coal or charcoal when it is burned, you can see in the beginning it will burn with a flame because of the vaporizable or volatile gases present in that. Volatile means easily vaporizable. In coal of charcoal also, some gases will be present in that, easily vaporizable gases. So when they burn, we can see in the starting a flame. After that, what will happen? It will just glow. So when wood or charcoal is ignited, the volatile substances present vaporize and burn with a flame in the beginning. A luminous flame is seen when the atoms of the gaseous substances are heated and start to glow. Now, the color produced by each element is a characteristic property of that element. Sometimes you can see it is glowing with a red glow. Sometimes we can see that yellow glow. This all depends upon which element is present. The color produced by each element is a characteristic property of that element. Incomplete combustion gives soot with carbon. So we have seen now in carbon the combustion reaction when saturated carbon compounds undergo combustion, a clean non-sooty blue flame is formed. Unsaturated carbon compounds undergo combustion, a yellow sooty flame is formed. Unsaturated carbon compounds also, if sufficient amount of oxygen is not available, undergo incomplete combustion and yellow sooty flame is formed. These are the points we learned in combustion of carbon compounds. And what are the products formed when carbon compounds undergo combustion? Carbon dioxide and water along with a lot of heat and light energy. Now you already learned the formation of coal and petroleum in your lower classes. These coal and petroleum are called fossil fuels. How these coal and petroleum are formed from the dead remains of living organisms. So let us see. Coal and petroleum have been formed from biomass which has been subjected to various biological and geological processes. Coal is the remains of trees, ferns and other plants that lived millions of years ago. These were crushed into the earth, perhaps by earthquake or volcanic eruptions. So millions of years ago, the plants, trees which were living, they, due to that volcanic eruptions or earthquake, they crushed into the earth. They were passed down by layers of earth and rock. So upon these remains of these trees, what happened? The rocks and earth layers, layer by layer, it got deposited over them. You can see here, they got deposited, mud and rock, all these got deposited over them. They slowly decayed into coal. So these dead remains of these organisms, that mean trees, they slowly decomposed or decayed into the coal. Oil and gas are the remains of millions of tiny plants and animals that lived in the sea. So same way only petroleum also formed. Petroleum, natural gas, all these are formed in the same way. So these are the coal, petroleum, this natural gas, all are the remains of millions of tiny plants and animals that lived in the sea. When they died, their bodies sank to the seabed and were covered by silt. You know what is silt? So these bodies were covered by the silt. Bacteria attacked the dead animals, turning them into oil and gas under high pressure they were being subjected to. So what happens upon this dead remains, this rock were layer by layer it got deposited. So due to this bacterial action, these dead remains of these living small plants and animals, they are converted into coal or petroleum or natural gas due to high pressure. Meanwhile, the silt was slowly compressed into rock. What happened to the silt? It was slowly, it was changed into the rock. So the oil and gas seeped into the porous part of the rock. What is meant by porous? Having pores, small holes. So through these small holes, the oil and gas seeped into the porous part of the rock. and got trapped like water in a sponge. You know, water that will absorb the sponge and it will be in between. How the water is trapped in the sponge. The same way in this rock, there were through these pores, these oil and gases formed which seeped into the porous parts and they get deposited over there. So how this coal and petroleum is formed? From the dead remains of the living organism like plants and small animals. So why these coal and petroleum are called fossil fuels? Because these dead remains of these living organisms, they are called fossils. So as these coal and petroleum are formed from fossils, they are called fossil fuels. Now next reaction what we are going to learn is oxidation. Let us perform an activity to understand the oxidation of carbon compounds. Take about 3 ml of ethanol in a test tube and warm it gently in a water bath. Why it is warmed in a water bath? You know, ethanol is an alcohol. Alcohols are highly inflammable. So directly when it is heated, it may catch fire. That's the reason it is heated in a water bath. This is a water bath. Next, add a 5% solution of alkaline potassium permanganate drop by drop to this solution. What is meant by alkaline potassium permanganate? Potassium permanganate in an alkaline medium. So you know potassium permanganate color is purple. So first we have taken ethanol in a test tube and it is heated in a water bath. To this ethanol we are adding alkaline potassium permanganate. Now let us see whether the color of potassium permanganate persists when it is added initially. No, the color of the solution fades and at last it disappears. It fades and then it disappears, or we can say the color of the potassium permanganate gets discharged. So how the reaction is carried out? 3 ml of ethanol is taken in a test tube and it is warmed in a water bath. Then alkaline potassium permanganate solution is added drop by drop to this ethanol. What we can see? The color of the potassium permanganate get discharged. Now again if you are adding potassium permanganate, the potassium permanganate color persists there. So why does the color of potassium permanganate not disappear when excess is added, more is added, why it is not disappearing? Let us see the reasons. The purple color of potassium permanganate gets discharged on warming the test tube initially. Alkaline potassium permanganate provides oxygen to carry out the oxidation of ethanol to ethanoic acid and its color get discharged. So why the color is getting discharged here? Because here ethanol is converted to ethanoic acid. That is an oxidation reaction. You have learnt already what is meant by oxidation. Addition of oxygen to a compound, to a substance, that is called oxidation. So here what is providing that oxygen? Alkaline potassium permanganate is providing that oxygen to carry out the oxidation reaction of ethanol to ethanoic acid. So that's the reason potassium permanganate color disappears or it gets discharged. Now on further addition of, once the oxidation is complete, again we are adding potassium permanganate that does not take part in the reaction. That's the reason its color persists. So how the reaction is carried out? Ethanol is taken and it is warmed gently in a water bath. To that potassium permanganate, alkaline potassium permanganate is added drop by drop. potassium permanganate color is purple. So afterwards we can see the color of the potassium permanganate disappears. What is the reason? Because potassium permanganate provides oxygen to ethanol for the oxidation of ethanol to ethanoic acid. That's the reason its color disappears. Further addition of potassium permanganate once the oxidation is completed, further addition of potassium permanganate does not take part in the reaction. That's the reason again when we are adding potassium permanganate, its color persists. So let us see. So all these carbon compounds can be easily oxidized on combustion. We have seen already it will be converted to carbon dioxide and water. So in addition to this complete oxidation, when complete oxidation takes place, it is carbon compounds are converting into carbon dioxide and water. In addition to this complete oxidation, we have reactions in which alcohols are converted to carboxylic acid. That example only we have seen now. Ethanol is converted to ethanoic acid. This is ethanol, CH3CH2OH, that is converted to ethanoic acid. So we have seen this reaction is carried out in presence of alkaline potassium permanganate. It is heated in presence of alkaline KMnO4 or potassium permanganate. This reaction can also be carried out in presence of acidified K2Cr2O7. K2Cr2O7 is potassium dichromate. It can be heated. So here, what is the role of this alkaline potassium permanganate or acidified potassium dichromate? They are providing oxygen to the ethanol to carry out the oxidation reaction. So, the substances which are capable of adding oxygen to others are known as oxidizing agents. So, what is the role of alkaline potassium permanganate here? That is acting as an oxidizing agent. What is the role of acidified potassium dichromate if you are using that? It is acting as an oxidizing agent. So, in oxidation reaction, we have learned alcohols are oxidized to acid in presence of alkaline potassium permanganate or acidified potassium dichromate. This alkaline potassium permanganate or acidified potassium dichromate are acting as oxidizing agents in this reaction. Alkaline potassium permanganate KMnO4 or acidified potassium dichromate K2Cr2O7 are oxidizing alcohols to acids, that is adding oxygen to the starting material. Hence they are known as oxidizing agents. So we have learnt in this today's class chemical properties of carbon compounds. There are 4 chemical properties we are learning in this lesson: combustion, oxidation, addition reaction and substitution reaction. Today's class we have discussed only 2, combustion and oxidation. Addition reaction and substitution reaction we are going to learn in the next class. So combustion we have learned organic compound or carbon compounds undergo complete combustion. Saturated compound undergo complete combustion and a clean flame is produced. When unsaturated carbon compounds undergo incomplete combustion and a yellow sooty flame is produced. Saturated carbon compound also, if sufficient oxygen is not available, it undergo incomplete combustion and yellow sooty flame is produced. And in the oxidation reaction, we have seen the example, alcohols are oxidized to carboxylic acids. Particularly, we have seen the example of ethanol is oxidized to ethanoic acid using alkaline potassium permanganate or acidified potassium dichromate. Here the alkaline potassium permanganate or acidified potassium dichromate are acting as the oxidizing agents. Hope you understood today's class. Thank you, children.